Okay, in this exercise, even though they say to solve by substitution, know that for this test you can always use substitution or elimination. And so I choose to use elimination because this is frequently the easiest method uh, um, that you can use to solve a system, which is basically starting with the original. The elimination method is basically multiplying one or two of the equations so that when you add the new system, they cancel, either x cancels or y cancels. So in this case, this is the original, and you can see that if I multiply this by 7, so that I have the same coefficient here in the second equation as 7, but opposite sign, then we get, so our new system becomes, I'm only changing bottom, so the top stays the same, but the bottom becomes negative 7x plus 7y equals 49. Okay, so this is a new system. It's we only changed the second one, but now you can see that if I add the two equations, the x cancels, so we get 10y equals 20. So now we can solve this equation for y, so I can divide by 10, and so y will be 2. Okay, and you can repeat the process. The idea is that I got rid of x by multiplying by 7, but you can also get rid of y. So the idea is that we can have also another system where instead of multiplying, so here's my original, but now instead of multiplying by 7, if I want to get rid of the y, I can multiply this by negative 3, so that my new system will be 7x plus 3y equals negative 29, and the bottom is 3x minus 3y equals negative 21. The idea is that now I can add those two equations, the y's will cancel, we get 10x equals negative 50, and now we can solve for x, so can divide by 10, and so x is negative 5. So putting all the x and the y together, our solution for this system will be negative 5 comma 2. Okay, you can also use substitution, but the idea is most of the times using elimination, you guys work faster, you can get to the solution, and there's no tracking of formulas. So post a comment in the Canvas Ask the Class Unit 3 if you guys have any questions about this type of